Alright, so for this particular problem I'm going to do 107 part C in page 314 of the chemistry book. So part C, I'm supposed to write a skeleton equation for the following reactions. And for C I have an aluminum solid. Okay, and I know aluminum to have a +3 charge. Aluminum solid plus a copper in parentheses 1, so that tells me that's a 1 charge, copper chloride, and that's an aqueous state. Copper I also know to have a -1 charge. So if I have a 1 plus 1 -1, then I know my ratios are 1 to 1, so I don't need to write anything in the subscripts. It's an assumed 1 already. So these two compounds combine to react and make aluminum. Oops, that looks like a 5. It should be a 3. Aluminum chloride. Okay, because I know aluminum to have a +3 charge, that means I need 3 aluminums per 1. I'm sorry, 3 chlorides per 1 aluminum. Okay, so aluminum chloride and copper solid. Now also that aluminum chloride is in an aqueous state plus copper. So that's my skeleton equation. Now if I also look at number 108, number 8 asks us to balance these equations out. So I'm going to balance these out. And if you remember, I need to make sure that each side has the same amount of each element. So I'm going to go ahead and write my underline here, because I'm going to manipulate the coefficients to even out my elements on the reactants and product side. So I'm erasing my charges because I don't really need them anymore. I'm gonna clean up my board a little bit. So I know now that I'm just working with coefficients and balancing out my equation. So I'm going to look for the biggest compound that I have here, and it looks to be aluminum chloride. Okay, I've got 1 aluminum and 3 chlorides, so I have 4 molecules there. So if I just go ahead and write in this, just for starters, just write 1. That gives me 1 aluminum. So here's my aluminums on my product side, and my aluminums on my reactant side, and my copper and my chloride. So I'll do the same on my reactant side just to keep count. So if I have 1 as a coefficient for this molecule, aluminum chloride, then that gives me just 1 aluminum on this side, which means all I need to write is 1 on that side. So my aluminums are evened out. Now let's look at my chlorides. Because I have one aluminum here on this chloride, on this aluminum chloride, this 1 distributes to the chloride 3. So this chloride 3, if I only have 1 of these aluminum chlorides, each of these molecules contains 3 chlorides. I only have 1 of them, so that means I only have 3 chlorides. Okay, so I distributed that 1. Now this 1 also distributes to the aluminum, which I already kind of counted out for. See here, this also distributes to my 1 aluminum. Alright, so I have 3 chlorines. That means that I need to have 3 chlorines on my product side. I'm sorry, on my reactant side. And you'll notice copper chloride only has 1. There's that 1 assumed chlorine there. So that means, but remember, I don't mess with the subscripts for these molecules. So that means I need to have a 3 as a coefficient, because that 3 will distribute over to chlorine, and that gives me now 3 chlorines, which matches what I have on my product side. So just as before, where the 1 distributes to the aluminum as well, this 3 also distributes over to the copper, which means I have 3 coppers in my reactant side, which consequently tells me now that I need 3 on my product side. And luckily copper is all by itself, so I just write a 3 here in my coefficient, and that equals out the, or that balances out my equation for number 107C, and also answering the question for number 108.